A pointer is just another type of variable. The difference between the pointer and every other type of variable is that instead of holding an integer value, or a string value, or any other type of value, it holds an address value. Specifically, it holds the address of a variable of our choosing, so that we can have direct access to the variable by simply calling our pointer. But what is the usefulness of this mechanism? Imagine that we had an array of 10 elements, and that we cannot access the elements by index. We would have to iterate through every element, every time, in order to get a specific one on a specific index. Instead of repeating the same steps every time, we could save the desired element by using a pointer. In fact, arrays actually have a pointer themselves. There is a place in the memory in which a pointer is stored, and when you call an array index, it actually refers to the starting block to which the pointer is pointing, and goes that many steps beyond to get the element at that index. That is why you cannot simply insert elements into an array, but you would have to make a whole new array and copy all the elements with the new element inserted. This is the reason why in languages like Java, when the array doesn't have enough space to insert a new element, it is usually doubled. A new array is created, which is double the size of the original array. It copies all the elements and then inserts the new element. First, we'll create a basic integer. It has an address space and a value. Pointers in C++ are denoted with a star. They must have a type because C++ is a strongly typed language. It requires knowledge of the type of variable the pointer will be pointing to. They are all differentiable by their types. If we wanted to access the variable the pointer is pointing to, we would have to derefer the pointer, which simply means getting the address stored in our pointer, and then the value which is stored on that specific address. Let's create a one-dimensional array. We start by initialization of our size and creating a pointer of a specific type. In this case, we'll use an integer. The array could be an array of any type or object. The word new specifies that memory will be allocated for our use. By using brackets on our size, we declare that we will allocate memory for 10 objects. Now that our array is created, we will assign our values. By iterating through the array with a for cycle, we output every element. The delete method is a very specific one. There is a difference between calling just delete and delete with brackets. Delete will just delete the object the pointer is pointing to. However, our array is dynamic. It is stored in the heap, and the allocator keeps track of the memory we use. When we call delete with brackets, it deallocates the whole array of objects. Let's go back to pointers for a bit and focus on how we would create a two-dimensional array. A one-dimensional array is just a pointer pointing to the beginning of an array. A two-dimensional array, on the other hand, is a pointer pointing to an array of pointers, each of which has its own array. Once again, we initialize our size. We create an array of pointers and then assign a new array to each pointer. We assign our values by iterating through each pointer and its array. We delete every array associated with each pointer, and then we delete all pointers.